Assalamualaikum. We from group 16. We will discuss about the signal conditioning in touchless faucet. Infrared transducers in touchless faucets confront a number of obstacles that require appropriate signal processing to enable precise and dependable performance. One of the key concerns in ambient light interference, which occurs when external light sources such as sunlight or artificial lighting affect the sensor signal, resulting in erroneous detection. This can be minimized by using optical filtering, modulation method, and differential sensing to identify the desired infrared signal from the background light. Another issue in signal attenuations. Another issue is signal attenuation, which occurs when an infrared signal weakens over distance or due to barriers, making precise object detection difficult. Signal application and additive thresholding methods can assist keep the signal strong and reliable. Electrical noise, which is commonly generated by the other electronic components or external sources, can create mistake in the infrared signal. Low pass filtering, adequate shielding and grounding, and differential signaling can all help to reduce noise damage. Temperature fluctuations can also have an impact on sensor function, resulting in drift or accuracy. Temperature composition methods and components with low temperature coefficients can assist the stabilized sensor output. Furthermore, reflections and diffusion from reflecting surface might result in inaccurate measurements by producing several routes for the infrared signal. These difficulties can be mitigated using advanced signal processing methods, bin shaping, and sensor housing design that minimize exposure to reflected sensor. Okay, for the second slide, we will discuss about non-inverting OM. The non-inverting operational amplifier, or OM, is a circuit in which the output voltage is in phase with input. It operates by connecting the input voltage signal straight to the OM's non-inverting input terminal. This produces a positive voltage gain, which is detected by the ratio of resistors 1 and 2. The closed-loop architecture offers high input independence, low output dependence, and consistent performance. Okay, from the circuit we use 7-for-1 operational amplifier, sine function generator, 1 millisecond oscilloscope, 180 kilo ohm resistor, and 1000 kilo ohm resistor. And we also use 15 watt power supply and 5 watt power supply for the input. Next, we will discuss about the band pass filter RC. A band pass filter is an electrical circuit that enables frequency within a given range to pass while attenuating frequencies outside of that range. It is characterized by two cut-off frequencies, the lower cut-off frequency and the higher cut-off frequency, which enable frequencies between them to pass through with little loss. Bandpass filters are identified by their center frequency, bandwidth, and quality factor. They are used in variety of applications, including audio processing, communicating systems, instrumentation, and medical equipment to isolate the amplified specific frequency components. Bandpass filters can be built with passive components such as resistors, capacitors, and inductors, or active components such as operational amplifier to improve performance. The pictures show the bandpass filter RC that we make. We use a 741 operational amplifier. We use two 741 operational amplifier, one capacitor 25 microfarad, one capacitor 10 microfarad, sun function generators, 10 millisecond oscilloscope, one 500 kilometer resistor, one 1700 kilo ohm resistor, 1600 kilo ohm resistor, and 1000 kilo ohm resistor. And we use 5 watt power supply and 1 watt power supply to give input.
Okay, for this slide I will explain the detailed framework for the circuit of signal conditioning. First, we got the infrared sensor. The infrared sensor we can see on the left side. We got the green thing. The green thing is a PIR sensor, and the blue thing is the Arduino. The PIR sensor will detect the infrared ray. It will move through the receiver. The receiver will become the input, and the input will go to the band pass filter. And the output from the sensor will become the input for the band pass filter. Band pass filter will remove the unwanted noise, and it will remove the low and high signal. On this band pass filter, we got 2 capacitor and 2 resistor and 1 ohm. Next, the output from the band pass filter will go to the non-inverting amplifier. On the amplifier, we got 2 resistor and 1 ohm. The non-inverting amplifier will improve the signal to readable signal for other instrument. So the output from the amplifier will go through oscilloscope. In this circuit design, we need a lot of wire and put in correct position. If not, the circuit cannot be done. So that's all.
Flow of the system. First, the input is the consumer that wants to use the faucets. In the faucets, the infrared sensor was applied to provide the infrared ray. The ray of infrared will be deflected by the hand consumer. The deflected infrared ray will be collected by the receiver of sensor. The sensor will give the signal to interpret the filter. The band pass filter will execute the unwanted noise and filter to fixed range and send to amplify. The non-inverting amplifier will improve the signal to readable signal and send to output. Output will allow the water to flow through the faucets. For the result, the fundamental goal of the non-inverting OM arrangement is to significantly amplify the input signal without changing its phase. The ratio of the resistors in the feedback loop determines the circuit voltage gain. Casually, because of the arrangement is non-inverting, the output signal will be in phase with the input signal, preventing phase shift caused by the amplification process. The intended behavior of the band pass filter RC circuit is to attenuate frequencies outside of the certain range while permitting a certain range of frequency to pass through. On the other hand, the signal will be greatly attenuated and have a much lower amplitude at the output if the input frequency is outside the passband. Then, in short, The band pass filter will selectively pass signal within a given frequency range and attenuate those outside of it, while the non-inverting OM circuit is expected to create an output signal that is greatly amplified and in phase with the input. When amplification and frequency selection are needed for signal conditioning application, these behaviors are essentials.